we're gonna look at end behavior, and when we're looking at it, either they both go up, the ends both go down, or you have one up, one down. If the exponent is even, then they're either both up or both down. If the exponent is odd, you have one of each, one up, one down. And then once you say they're both even, now your choice is, are they both up or both down? When it's positive, the ends are both up, and when it's negative, the ends are both down, which is the same as a parabola. And then for an odd function, if you know the exponent is odd, you have one up, one down. If it's positive, if you look at this from left to right, your eyes eventually go up for a positive, and if it's a negative, your eyes eventually go down. I've used the graphs of functions that you're most familiar with, the x squared and x cubed, and then you can extrapolate that for x to the 19th power or x to the 14th power. The only difference in the graph is if this is x to the 14th power, it's still going to have this basic shape, but it has a few more bumps in it. But if you were standing back from it a long ways, you probably wouldn't notice the bumps. Okay, so let's take a look at a handful of equations. This one here, my first thought is x to the 6th power, so it's even, so they're either both up or both down. But because it's a positive in the front, I know that they are both up. So if they're both up, it rises to the left and it rises to the right. Okay, this one here, the exponent is even, so that tells me that the ends are either both up or both down. But then it's a negative in the front, so I now know that they're both down. So if they're both down, as I go to the left, it's going down, and as I go to the right, it's going down. Okay, this one here, I have an odd degree. So if it's odd, it's one up, one down. Then the question is just which way is it? So if it's negative, as you move your eyes across the graph from left to right, your eyes will eventually go down. So picturing this versus this, if our eyes eventually go down, it starts up and eventually goes down. So it's going to go, rises to the left and then falls to the right so that eventually your eyes go down. Okay, this one odd exponent, so we now know it's one up, one down, and then the question is which one? So if it's positive, your eyes eventually go up. So if your eyes eventually go up, it's going to start going down. So as you move to the left, it's going down, and as you move to the right, it's going up. Okay, then sometimes the equation in front of you is not multiplied out. Here's an example. I could multiply this whole thing together, but I'm going to show you a shortcut. But just to show you in general what you'd be doing, if I were to multiply this, I would expand it. Then I might FOIL 2x plus 3 times 2x plus 3 and combine the middle terms, and I'd have that. I'd FOIL these two together, and I'd get that. Now that I have 3 terms times 3 terms, I'd take 4x squared times each of those, 12x times each of those, and 9 times each of those. And I would finally have my polynomial. That's a lot of work when all I care about is the leading term here. I really just need to know that it's even, so they're either both up or both down. It's a negative in the front, so it's both down. So eventually I know that it falls to the left and falls to the right. But we want to be able to get negative 12x to the 4th without doing all this multiplication. So what you can do is just multiply all of the ones in the front. So what I mean is, in this one right here, 2x plus 3, the leading one is 2x, but there's two of those. So there's 2x plus 3 times 2x plus 3. So I've got 2x and I have another 2x because they're in the front. In this one right here, x plus 1, x is in the front, and there's only to the first power, so there's just one of those. So x. And then this one right here, negative 3x is in the front, and there's only one of those factors, so just one of those negative 3x's. If I multiply all those together, 2x times 2x times x times negative 3x, 2 times 2 times negative 3 is negative 12, and x times x times x times x is x to the 4th, and see how I get the same thing without doing all that multiplication. And then I know it's even, so both up, both down, negative, so both down, meaning going down to the left and down to the right. So here's one more example like that. Okay, so for this one here, if I was going to multiply this all the way out, it would end up looking like this. And I don't want to have to multiply it all out. So using my shortcut of just multiplying all my leading terms together, okay, negative 4 is one of them. And then in x minus 3, x is there in the front, and it's to the first power, so it's just going to be a single x. Negative 2x plus 1, negative 2x is in the front, and it's to the first power, so it's just one of those. And then negative x plus 4, negative x is in the front, but it's to the second power, so the negative x, there's a couple of those. Multiply all this together, 1, 2, 3, 4 negatives, even amount of negatives, so it's positive. 4 times 2 is 8, so I have positive 8. And then 1, 2, 3, 4, x to the 4th. So I have positive 8, x to the 4th. Even, both up, both down. Positive, so both up. So it's rising to the left and rising to the right.